Economic Commission for Europe. I have a background in nuclear energy. Previously, I used to work in India for the Atomic Energy Commission from 1988 to 2009 in the nuclear fuel cycle development. From 2009 to 2016, I worked in the International Atomic Energy Agency as a nuclear technology specialist. And from 2016 till date, I'm working in the UN Economic Commission for Europe in the Division of Sustainable Energy as Economic Affairs Officer. UNECE, or the Economic Commission for Europe, is one of the regional commissions of Europe, one of the oldest UN agencies, which was built, it was established in 1947 after the Second World War with a mission to rebuild the energy system of the Europe. So when we gather together in this virtual forum to discuss about nuclear energy, it will be good to have a look at the background in which we are gathering together today. We can see that we are in the midst of an history in making. If you can be an optimistic person, you can be a pessimist, but it cannot be debated that the world is going to be changing in drastic ways from what we see today. We are talking about bending the curve as well as the COVID infections are going. But the major curve which we have to bend, the root cause of all this could be the carbon emission curve. If you can see the slide now, I hope everyone sees the slide. We have the carbon emission going up in that orange line, which is a business as usual line. And if we want to attain 1.5 degrees Celsius or 2 degrees Celsius goal, that curve has to be bent down. The carbon emission of the whole economy, of the whole society has to go down drastically to reach that goal of 1.5 to 2 degrees Celsius rise in temperature above the pre-industrial levels. So this is a major challenge. And if you don't do that, the things are becoming very, very apparent today. 2020 started not with the epidemic. We had a bigger problem going on during the end of 2019, start of 2020. Massive forest fires have happened in the most dry and warm regions in Australia. It has been ranging in the Amazon, which is a wet place in Brazil and Bolivia. In some of the wetlands, forest fires were happening. In the Arctic, in Canada, Greenland, and in Russia, we had forest fires. So we had forest fires in the hot, dry regions. We had it in wetlands. We had it in tropical areas in South Asia, Philippines, Indonesia, India, Malaysia, etc. All happening last year. And we have an estimate only from Australia saying that where in Australia we had the biggest forest fires. We had more than 1 billion animals died in the forest fires in Australia. So the biggest calamity, can you think of a calamity which has killed 1 billion animals in any recent event? We may not be able to guess an event of that magnitude happening in our historic times. So that was the background in which we opened 2020. And immediately we saw the pandemic, which has so far killed, took the lives of more than 200,000 people. Animals have suffered more than human beings in these last few months. And we don't know how these events are related, but we know that climate change is destroying habitats, which is making all these viruses or wild animals coming closer to human populations, and there could be a jump of a virus from an animal to the human being. So what the message that this few months of events, drastic events.
Sorry. Two little things. Could you just put it in full screen, like in slideshow? Yeah. And second thing, we're a bit late on schedule, I must say. So if you could speed up that would be great. Sorry.
Yeah, thank you very much. Can you see the slide now? Because
yeah,
okay.
It's better. Thanks.
So we really reinforced our message that sustainable development is where we should be going, and sustainable development is a key message which was talked from 1987s, and two words which were used very commonly was integrated and indivisible development, and it is all that is about what we are talking today, how we can connect to one sector of the society, of the economy, to another sector of the economy or a society. That is the biggest technological challenge, biggest political challenge, biggest financial challenge, biggest regulatory challenge. So I have this figure on the right side of the presentation, which gives a wheel of what nuclear energy can do to each of the 17 sustainable development goals, which were agreed by all the countries. Sorry if you cannot read it, but we have a line that says that nuclear technology and nuclear energy has got a significant role in all the 17 goals. And we talk about SDG 7, that is on clean electricity, clean energy. We say that energy underpins all sustainable development, and nuclear energy has got a role to play. It should be part of the conversation if we are thinking of sustainable development in an increasingly urbanized world, where 70% of or more people will be living in cities. We are extremely constrained with the land which is available for energy generation, and we have to support food, energy, water nexus. And this is the biggest challenge we have today. But what is the problem? The nuclear energy being part of the conversation has to do a lot with how it is being communicated to the public. We can see that about 2/3 of the world population in many countries where survey has been done, 2/3 of the population are opposing nuclear energy. And we have only about 1/3 of the population which are supporting nuclear energy in general. So in some countries, it is, very large support of nuclear energy. In some countries, very poor support of nuclear energy. But in general, we can say that the world over, about 2/3 of the population doesn't understand nuclear energy properly and doesn't support it in the right way. So we have to move from emotions to facts now and see how nuclear energy could be part of the conversation. Energy and climate related goals have a bearing, and nuclear energy is one of the clean, low carbon energy sources which is out there, and it has to be part of the conversation. Nuclear energy could create a platform for innovative engagement. It is not just about energy, it is about desalination of water, it is about production of hydrogen for clean transport, it is about production of fertilizers for food production. So how nuclear energy could create a platform for innovative engagement with others is one area which we have to think. And the conventional model of nuclear energy as just another energy commodity has to give away to a new model of nuclear energy as a critical energy source for meeting global sustainability objectives of energy and climate action. So this is all I have for the start. Thank you very much for your patience in listening to this short conversation. Thank you.
So maybe we do a little thesis of our workshop. Maybe we start with fission. So maybe who wants to start? Maybe Tulsidas. I'm sorry, I heard you had a problem. I couldn't make it to solve.
Yeah, thank you very much. Very briefly, we had very little time to discuss a lot of things, but the things we discussed is how nuclear energy can solve the larger problems of the society. We were thinking about sustainable development, and one point that was discussed is clean cooking fuel is not available to a large population of the world. And because of that, about 4 million people die every year due to indoor pollution. How nuclear energy can help? Definitely, the present way of nuclear energy functioning with large nuclear plants will not help situations like that. We have to go to remote communities where off the grid 24-hour electricity supply. If it has to be given, then we have to think about small modular reactors. We have to think about reactors which could be of smaller capacity. Secondly, we were discussing on the disadvantages of nuclear energy. 3 disadvantages stand out. One is safety, second is economics, and third is non-proliferation. That is use of nuclear energy for weapons purposes. So we have discussed some in detail about economics, and we have not gone into other areas so much. But we think that nuclear has got a high cost in several cases. We have seen the new builds happening in Finland and France, which has got a high cost. But from my point of view, nuclear energy is different from other energy business because all the capital cost that is required for nuclear is required upfront. It has to be sunk before the energy supply starts. After that, operations and fuel cost very little. And there was a discussion on how much resources are there for nuclear energy to become more expansive. If more countries start nuclear energy, is the uranium enough? The answer is it is not enough. If you want to change the whole energy into nuclear energy, we will not be thinking about uranium only. We will be thinking about thorium. We will be thinking about fusion. So there will be multiple nuclear technologies that are available. So it is not just based on uranium that nuclear technology functions or could contribute into future. So this is how I can conclude what we were discussing.
Thank you, Hari. Perhaps, Oskari, would you like to give us the insights of your sessions?
Sure. So again, we didn't have much time, but we tried to talk about what are the challenges that nuclear faces as the technology. And we glanced over the fact that, well, there's radioactive waste and ecological danger potentially due to accidents that need to be discussed in the debate. And of course, the proliferation issue, since nuclear is an inherently strategic technology and therefore always has the possibility of being weaponized or being used as a strategic resource. And from these challenges, I tried to introduce what are the proposed solutions in terms of technology, notably generation 4 reactors and reprocessing in order to make it more sustainable. But these technologies all have the cost of being proliferant in a way, and therefore being of strategic interest and therefore difficult to implement on a wider scale. And I guess that's it.
Thank you. Perhaps could you give us, if you have, any insights regarding the bad reputation and perhaps the overly proportionate bad reputation that nuclear energy suffers, especially with regards to casualties per energy that was generated using nuclear power plants compared perhaps to fossil energies?
So overall, I'd like to say that comparing lives is a very delicate task and cannot be done simply by comparing numbers, and the context is always important. However, there exists calculations for deaths per terawatt hour, for example, and nuclear comes out of the top, as in, despite accidents and the ecological damage caused by certain accidents, the overall operation, the deaths per operation hour and terawatt hours is significantly lower than for wind or solar, for example. And that is an important factor if you want to weigh lives. But weighing lives and knowing something in hindsight is, well, considering the current situation with Corona, hindsight is always powerful, but it's difficult to forecast in such complex systems. And whether weighing lives is the right metric is also debatable, because it all ties into resource usage and their relative impact, which is often not really measurable.
Perhaps before we move on to fusion, there are 2 points that I would also like to discuss. The first one is the sustainability in terms of resource availability, and also in terms of a means to combat climate change. You mentioned that based on current usage, uranium should last about 100 years or so, perhaps 200. Do you think this gives it a justification to be used as a sustainable energy source?
If I can come briefly on that, we have advanced reactor generation 4 reactors, which are fast breeder reactors. So for every ton of material used in the reactor, we will be producing more fuel from the reactor itself. So this is one technology which gives unlimited lifetime for nuclear resource base to be expanded. Of course, there are technical difficulties, but it is a proven technology. Fast breeder reactors, experimental reactors are still running in India and in China. In India, there is a demonstration reactor which is being built. Earlier, there was construction going on in the US, but because of the policy issues, it was all discontinued. But from a resource point of view, generation 4 reactors, this is one point. Then after uranium you have thorium, which is energy material, very, very powerful energy, dense energy material, which is not at all used in a big way so far. But we had, again, experimental reactors running on thorium. Even in Germany, there was a thorium high temperature reactors running up to 1980s middle. After the Chernobyl accident, it was closed. The same technology was taken over by China, and China is now has started a new reactor using not thorium, but uranium to start with, but which they can use thorium also. So
once we have these technologies implemented, the time scale of use of nuclear energy as a power source, it becomes less of an issue. But that brings me to the other issue relating to the problem of climate change. So as you probably heard, in order to avoid the most severe consequences associated with climate change, emissions need to go down very rapidly. So on the order of the mid of the century, so in about one human generation. All of these technologies that you mentioned are still somewhat in experimental phase. Do you think it's reasonable that they will become widespread in an amount of time that is useful in the context of climate change?
Briefly, yes. Even though technology was difficult, but these were the same technologies which were developed in 70s and 80s. And if you remember nuclear energy, the first generation reactors, large number of reactors were built in France, in US, in Russia in a very short time of 3 to 4 years, using the technology of that time in those days. So I think it is worthwhile to think whether we can build advanced reactors also in that same fast pace today. And if there is a policy, regulatory support to that, definitely it can happen.
All right. And maybe if I can add something, I mean, we are in a transition phase, right? So if for now, conventional fission plants can do the job, right? And even if the fuel runs out, maybe in 100 years, it buys us the time to develop the other options.
Yeah,
so
correct. Yeah, the current generation reactors are not inferior in any way. We talked about the safety of those reactors. The technology is very well suited to end of the century, and it can run safely. And by that time, you can have a faster rolling out of new technologies also. That's
a fair point. I would only perhaps add to this that the time scale of 100 or 200 years is based on the current usage, and the current usage of nuclear energy is about on the order of perhaps less than 10% of global energy consumption. So if we want to decarbonize with nuclear energy, we would need far more, and thus the time scale with current technology would become a lot lower, smaller.
So this would require the uranium price to go up, and if uranium demand increases enough, we will be able to use different extraction technologies and therefore increase the reasonably assured resources, and eventually seawater extraction will become profitable. And at that point, we have great access to uranium and extending these by hundreds of years again.
Mm-hmm. All right. Let's not forget fusion. Perhaps the speakers of the fusion workshops could give us their conclusions of the breakout sessions.
Maybe I start, Justin, if that's fine.
Yeah, sounds good.
Because it makes, I think, more sense, because we talked mostly about where we stand today. We discussed the current roadmap, mainly of the European fusion program, of how to develop fusion and what challenges it faces. And then we discussed mostly how this process can be speeded up the most. So which are the most important elements to get fusion as quick as possible. So we talked about, of course, more funding would help, probably stronger links with industry, also attract as many young talented people as possible. I would say what clearly came out as the main need was to do more successful communication in fusion, and both on the level to just educate or inform each and everyone about the prospects and the advantages of fusion and the interest, but then also to actually attract people to enter the field and work on it. And we discussed different means of how this could look like. So we talked about tours, which are done regularly, for example, at EPFL. Then also maybe do exhibitions in different places to also reach people which are not close to actually a fusion research facility. And also use social media. And I would say especially the social media part is still, we did not go very deep into that and what would be the most efficient way to do so. To attract people in the field, I think it was a consensus that it has to happen mostly at the high school level, which would probably be the most efficient. And then the question is, what would most efficiently attract these people? Is it, the prospects to do very interesting research? Is it just the main interest to do something good for the future? And it seems this was the opinion that maybe more than it used to be, young people really want to do something good for the future, for humanity or for the planet. And so this can become more and more of an argument maybe to join fusion or another energy research field. I would say this was our conclusion.
Thank you. Justin, do you have anything to add to that?
A little bit. So I was more looking and discussing about the more long-term implications of fusion. And so, of course, one of the main crucial issues, of course, that came up was the entry time of fusion, of when fusion becomes able to actually put electricity onto the grid is just completely crucial for how things play out. And so I think, of course, Christian's discussions were very valuable to that. I was also surprised that, maybe this is because it's a nuclear forum, but it was, there's quite a consensus that a base load source of electricity was necessary even in the future. And so I think when you talk to sustainable energy fans more broadly, this isn't quite as uniformly accepted, but it's something that was really strongly believed in the discussions I had. And then the last thing I want to mention that Christian already discussed was the importance of communication with the public. It seems like even in environmental circles, even in people that are paying attention to energy technology, that fusion isn't that well known. And so in one sense, it's a bad thing because they're not really keeping us in mind, but it does mean that there's going to be a critical phase when basically we get to make our first impression. And so I think communication with the public, especially during that crucial period, is important. And I mean, personally, I think that it will probably come when ITER is first turned on, which is a big fusion experiment that should be the first device to produce net fusion power. And so I think that's when it will kind of jump to the headlines, and that's when, again, a good first impression is really important.
Any timeline on that?
I mean, so the official Eurofusion fusion timeline, I think, is, you know, early end or what's it, 2050s, 2060s. So basically early part of the second half of the century.
This would be
Or
a power producing
yes.
reactor, really, but ITER would be in the 30s.
Yeah. Okay. Yeah, this perhaps brings me also to the point that I addressed earlier with regards to new generation of fission reactors. So there, I'm sure you've heard people have this issue with fusion energy, saying that for one thing, we already have many technologies that enable us to generate energy and electricity for the society in a sustainable way, especially with regards to carbon emissions. So we should put all our money and focus into that to make a quick energy transition possible. What do you answer to people like that? How do you justify the time and energy and money spent on fusion?
So I mean, I don't believe that we've identified at this point a demonstratively technically feasible way to get off of fossil fuels. And so until we have something that we're confident in, I think we should pursue a broad range of different strategies. And I mean, for sustainable energy, there's really only three options, right? You have all renewables together, you have fission, and you have fusion. And so some combination of those has to be our solution. And it's too crucial of a problem to be picky and to start throwing away potential solutions.
Okay, thank you. Does any of the participants have a question that they would like to get off their chest? That doesn't seem to be the case. Well, then in that case, I would say that we take the chance to conclude our session more or less timely. I would like to thank all of you for the very constructive discussions and interesting talks. And yeah, thank you for joining us.